All right, thanks for coming to the stream today. Today we'll be covering Jurassic Park. Jurassic Park has SQL injection in it. It's a pretty cool little themed room to get you to see a little bit of manual and SQL map injection, and then moving on from there and SSHing into the box, and then finding different flags based on that information. And so with that, we'll get kicked off. So here's Jurassic Park. This one is a room on TryHackme. This is a subscription only room. And what we'll go ahead and do is we'll start scanning the box first and see what ports are open and then move on from there. So with any room, we'll go ahead and set up our targets file. So we'll create our targets. This is the IP address of the box. And this is a good way to keep track of the systems that you're going to pen test or work on. So we'll start off with that. nmap-il for an input list. We'll do that targets file, and we'll then do a -pn -t5. PN's no ping, and T5 is the speed that nmap will do it at. That's the fastest speed. And then we'll output all formats and call this init park. So we immediately get a response back, and we have SSH and HTTP. So we can go ahead and do our more detailed scan, and we'll look at the page and also go ahead and get GoBuster going after we get the scan started. So we'll do detail, we'll do script equals default version phones, and let's do HTTP all. We'll put a script timeout. Some of the scripts in nmap do get hung up after a while, and so by putting a script timeout, we prevent nmap from hanging up. We are giving it a 2-minute timeout, and we can just do, that should be good. Oh. So I had an error in there, and I should have done vuln instead of vulns. There we go. Apparently I still had an error. Didn't spell versions right. There we go. All right, while we're waiting on that, we'll also go ahead and get GoBuster going. So GoBuster -u, we want to put in this address here. And this site has sound on it, so if you, I don't have the sound playing, but if you were doing the site on your own, you would have the sound there. So, something to be aware of if you all of a sudden just get sound blasting on your speakers or anything like that. We're doing word list, Buster. 2.3 medium, and then we want to save the output, and that's going to be gobuster.txt, and -t for threads, and we'll put it at 10 threads. So GoBuster again is going to be trying multiple words from the word list and trying to pick those up. So we do see that assets came up. While the scans are kicking off, we'll go ahead and start playing with the page. So we can see there's not much here. We do have an online shop. If we open up the online shop, One of the things to kind of note is that we are seeing .php as the extension. So this is good to kind of note what kind of technologies are used underneath here. We have a couple packages. We see that we can buy the basic package, which has an ID equals 3. And usually when I see this type of stuff with these ID numbers, I like to try different ID numbers. And we can see that by me changing it to 4, there says there's no results found. Changing it to 5, we get something back. This one has an interesting message where we can kind of see why have you blocked these characters. And so we can see that there might be a waft involved. So we see that certain characters are blocked. In particular, the single tick, the pound sign, drop, dash, username, at, and 4 dashes. So if we did a quotations, we see that we got a SQL error message, and this indicates that there's some kind of SQL injection in here. If you can't see that, let me make that bigger. But basically, it's saying that the error in your SQL syntax, check the manual that corresponds to your MySQL Server version for the right syntax to use near. And there's that quotation mark that I put in at line 1. So this kind of gives us an idea of what's happening in the background. If you've never seen SQL injection statements, what they kind of look like are that they say select all from, and then it's a table where, in this case, ID equals whatever. And so what we're doing here in this case is this query gets wrapped up like this. And normally what you'll end up doing is putting like 3, right? What we're doing is we're breaking that SQL query by putting in that quotations mark there, and now it doesn't have a valid URL to follow or query to make. And so this kind of highlights an area where we might have that issue. And so we can play with this. We can understand this a little bit more, see if we can get more data out of this, things like that. We can do, so we have 5. 5 is the one that we were, let's zoom this back out a little bit. There we go. And let's see if we can understand what's behind this. So what we're doing is we're trying to complete a better SQL statement. So we're taking the value, whatever the SQL result is, and we're doing a union statement, and we're doing a union select. And then what we start doing is we start walking this, and this is to determine how many columns there are. So we'll do 1, and you'll see that the useSelect statements have different number of columns, and this kind of indicates, okay, we're trying to combine the data, but we don't have enough columns to match that. So if we do 2, and then 3, and then 4, and then 5, and we see that the page displays correctly, but you'll notice that the page is different a little bit. And now we see like 2 up here, we see that the price is 3, that 5 of these packages have been sold, and then the number 4 here. And that corresponds to what data was taken out of the database, and it just basically replaced it with the numbers that we provided here. So 1 doesn't show up on the page anywhere, but 2 shows up here, 3 shows up there, 4 shows up down there, and 5 shows here. And we can try to see if we can get any more information out of this. So we could do version. And now we see that that 4 got replaced with the version information. And so this is where you kind of start playing with the little manual portion of doing the database. So I'm going to see what our tasks are here. We need to figure out the SQL database. How many columns does the table have? We figure that out. What's the system version? The system version is basically there now. So you'd have to convert that to figure out, the exact system version. So you take that in, just put it into Google. And then, so for the database, we would do database. And you see it as park. So this is a good track. We have an idea of that there's some kind of SQL injection in here. So normally what you do then is you would use SQL map. Unfortunately, SQL map's not valid for the OSCP. I don't agree with that, but again, if you're on a real pen test, this is more like what we would do. So for SQL map, what we're going to do is specify the URL. You put that in single ticks because, again, your URL does have special characters, and you want to make sure that the tool interprets those and not just bangs them up via bash. And so then what we're going to do is specify a random agent. And then we want to do a tamper script. We saw based on the comments that there's going to be some kind of WAF or something, preventing us this. And so if you get output or things like that where it's saying that this isn't working correctly, then that's where you want to do a tamper script. We're going to put the output directory and we're going to put it in SQL map. So everything looks good here. All right, so it's making requests to the server. It has identified that the ID parameter is injectable. It does look like the backend database is MySQL, and we kind of figured that out by when we were issuing the database command and the version command. Those are specific to MySQL databases. And so we're going to tell SQL map, yes, you can skip other payload tests. Again, we're trying to just get to this as quick as possible. Now it's asking, do you want to include all tests for MySQL, basically? And so we will say yes and let that kind of do its thing. It's starting to do some of these tests, and it's figuring out that it got Boolean based, it's error based. And so Boolean based is where it's trying to achieve true statements or false statements. Error based is when it's getting errors back. Time based blind is when it's injecting sleep commands, and if the website sleeps longer than normal, then that kind of flags that. That could be a false positive sometimes, and you need to know that. When you're doing a tool like this with SQL Map, it's basically querying the website, so it's putting it under a load, and these tools can sometimes think that it's time-based blind because that load is causing extra stress on the server and ends up basically making it response slower. And so then it thinks that there's just some kind of time delay basically. So SQL map finished up. It said that it's vulnerable. The ID parameter is vulnerable. Did you want to test any others? There were no other parameters. Again, we just had that one parameter. And once it gets done, what it's going to do is it's going to provide you the different types of parameters here that you can basically use to make valid queries. And we see these here. We have a payload of ID equals 5. That's the one that we had. And then it does an AND value here. And it just has a number equals a number. And this is to kind of show a Boolean based. Boolean AND is saying that, I want these results only if this number and this number equal the same. So this is good. We're able to successfully get a hold of this database. We are able to pull data out of this now. So now we need to move further down this path. To understand what's going on, we can now take away all this, the random agent. Um, Actually, we can just leave this in here. Let's leave that in there. We'll leave the random agent just in case there is some kind of um, WAF. We'll put the tamper back in there too. So tamper, what it's doing is it's SQL map has a bunch of standard queries that it tries, and so tamper tells it to do something different with those by either encoding it or using something different. In this case, we're just doing between, which is a tamper script. We want to see what tables are on the database. So we're doing dash dash tables, and so it's going to query those. And you can see this is all the tables, the information that it's pulling out right now. And so there's a lot of tables, and with most PHP applications and MySQL applications, there's a lot of tables that need to be there to kind of handle the connections, handle all the system data, things like that. And you can kind of see that that's what we're doing now. We're pulling out system, we're pulling out like table lock, table used, index, status statements, things like that. And so what SQL Map's doing is querying all this information, getting this, and it's building like a almost an internal database of what's going on. All right, so then there's all the tables that it pulled out, and there's a lot. There's quite a bit. We have also different databases that it pulled out for each one of these tables. So let's kind of scroll up a little bit and look at this information. So we see the information schema. That's part of a normal MySQL database. This kind of sets up like the engines and system tables, your standard schema, things like that. Then you have a database called MySQL here. We have DB event, column privileges, proc. Again, this is another standard MySQL one. And then we have a Park database, which that's not a normal one. We have performance schema, that's another normal MySQL database. And we have a system database. Okay, so we now are going to try to dump the database of Park and get the information out of there. And so SQL Map's going to use the information that we had from before, and we can see that this information is getting dumped from there. And then it presents a nice little table for us. And we had two different tables. We have users and we have items. For the users, we see that there are passwords, and that was kind of the interesting thing here is that we have these usernames, and then under the items we see different information, and we have like a Dennis there, and that's the only kind of information that we had further on this system. So with the passwords and with the username, what we try to do then is SSH into the box. And so we're gonna do a SSH. We'll do Dennis based on what we saw here, and then we need to do it towards the IP address that we have. And from before, we have two options for passwords. We have don't at me and I ate dinos. So we'll try the first one, and that didn't work. And so then we'll try the second one. And we're in. So now we have access to the box. Um, and for this one, we're looking for contents of flags. And so the finding of the flags was kind of interesting in this scenario. Again, this one kind of demonstrates a vulnerability that you would normally see, but then kind of adds the CTF element into it. And so they just want us to find these flag files on the system. So first you could look at ls and see what's there, and we find flag.txt. So um, if we look at that flag.txt, we can read that. We are Dennis, so we could cat that flag out. And the next one that we need to do then is the second flag. So the second flag, we're not really given a clue or anything like that. But what you normally want to do is when you get on a box is we did an ls-a, and that shows al, and it shows us all the details for the files in our current directory. And one of the big ones that I want to highlight out is this .bash history. We see that this is not pointed to dev null, which sometimes is, and that means that that history of what was on the terminal before us should be in that file. So we can cat this out and see what the user was doing before us, and see if that gives us a hint. If I can type. All right. So we can see we found flag 3 by that. So we could put flag 3 into the box here and go ahead and knock that one out. But we're still looking for the second flag. So we want to see what else that they did. We can see that they did a sudo-l, so they're listing out sudoers. Then they were trying to SCP something, find something. They did a vim. Etsy password. Looks like they're moving files around. They moved the flag 5 to some IP address. All right, so that didn't give us too much information. It gave us another flag, but we did see Vim. So another thing with Vim is, if you didn't know, is that Vim also saves its data so that you can see it. So when we looked at the files, we see that there's a .vim info, and so we could also do that. We can cat .vim info, and we can look in this and see if we find any information. So we are seeing, let's see here. So there was a vim flag 4. He vim flag 1. We already got flag 1. We're good on flag 1. There's a flag 2 though, and we see it right here. So let's see if we can, if that's still valid. So we'll cat that file out. Oops, we gotta add the slash before. All right, and so then we got flag 2. So we're flag 1, 2, 3. There was no fourth flag, and then we need to find the fifth flag. All right, so let's see if we can find that fifth flag. We can do cat test sh, and it looks like maybe this this binary can do that. So we need to look. So the test sh looks like it's supposed to do a bin bash and then cat the root flag. We see that it's running as Dennis though, and that it has permissions to Dennis, so that's not going to help us out. If this had root and it had the sudo bit, then that would help us out. That would give us that ability to do that. We did see that the user earlier did do a sudo -l, and we can see that, okay, as Dennis, we're able to run bin scp. Okay, so that's an interesting one. So let's see what we could do with that. If you don't know, we can do GTFO bins. And so these are binaries within the system that will basically give you access to other functionality. And so the one that we were looking in particular is SCP. And you can basically run SCP and get a shell. And so that's what we're going to do. We're going to copy this here, and we're going to go back and see if we can get this as a shell. And it looks like we are still Dennis. So that did not help us. Can we cat the shell? Let's see if we can still cat that. Nope, permission denied. So let's look back at the GTFO bins. Maybe we didn't copy something correctly. We have a file upload. There's another sudo. So let's try this sudo. We'll get our shell back. We'll do a bin bash. Okay, there's our shell. Let's clear this out so we just start with a fresh one. And now we're going to paste in that sudo. It's asking us if we're sure that we're fine with that. We'll do yes. And now we did get the $sign, which is usually indication of us having root. And if we do a bin bash, we do see that we do have root, and now we can do cat root flag 5. And that's it. That's the box. That was this one was a pretty cool one. It kind of gives you, the ability to practice a little bit of SQL injection. You can practice a little bit manual. If you're looking for more into the SQL injection and how to do that, what I highly suggest that you do is go back to SQL map and do a dash like VVVVV, and it'll show you exactly the commands that it's doing as it's working through to figure out which attacks work correctly. And just to kind of highlight that, I'll show you real quickly. Let's see, was it on this one? Yeah, that was on this window. Let's exit out of there. Exit out of that. Exit out of this. Exit. Exit. Thank you. All right, and then what we'll do is and so here's the traffic in and traffic and the response and stuff like that. So you can see exactly here is the URL that it was using, and then the response that I got back. So you could copy this link here and put it up here, and now you can kind of see some of the information. Now, because of the WAF and things like that, you might get some of this stuff that's preventing it, and that's because the URL bar is going to convert it back to some of the characters that are going to get caught, where SQL Map doesn't do that. But you get the idea of how this command's working to basically get access to that data, and that's what really matters. All right, thanks everyone. Have a good one.